All right, so now let's get some numerical error. So we're going to do problem number 5, and actually I may throw in just an extra sheet of paper here to make sure I'm not writing it all over the place, but we'll see. So let's do 5a. It's going to be 12.2 plus or minus 0.2 plus 15.7 plus or minus 0.1 plus 26.3 plus or minus 0.3. So, first of all, our error propagation, we're going to add up all these errors since that's how the addition subtraction formula works. So I'm going to get plus or minus 0.6. And then to add the numbers together, that's going to be 12.2 plus 15.7 plus 26.3, and that's going to give me 54.2. Okay, so this is 54.2 plus or minus 0.6. Okay, now here when we subtract, we've got 12,300 plus or minus 500. And let's be clear, we got sig figs out to hundreds here, so we got to be careful. So when I subtract, let's see, 12,300 minus 7,940. So for B, I'm getting a number 4,360. But I gotta round that to hundreds here because of the number of sig figs, because I've just got that one version of sig figs there. So I'm gonna end up basically getting 12,400 plus or minus 600 tons. So let me be clear. To get the error propagation, it was 500 plus 50, which gives me 550, and I need to round to even, so that's how I'm getting 600 there. Okay. Now, here I've got to, it says 45 plus or minus, plus or minus, plus or minus. That's, you know what? I don't even know what they're trying to write with C, so we're just going to skip that one. That's just stupid. Feeling very judgy. Okay, now this next problem. We're uncertain to within tens, so let's be careful when we subtract these. So I got 679 minus 1890. You can get negative numbers. That's totally fine. And so I'm getting negative 1210 when I subtract. My uncertainty is going to be 40 plus 2, and I got to round that to just plain old 40 newtons. So that's problem number 5. Now, I'm going to do 1% error calculation just in the interest of time. And I want to actually have you kind of check these on your own. So for 6, I'm going to call it 6a. So for 6a, I'm going to take 0.6 divided by 54.2 times 100. And when I actually check that, that's going to give me 1.1% error. Okay? So I also took it to one decimal place. What I'd like to ask you to do, please, on your own, fix 6b, 6c, and 6d. Okay? So that's problems 5 and 6.